A quadrilateral, that is a four-sided figure, has two sides which are parallel and equal in length. So here we have a picture of a quadrilateral, and I'm showing the two sides that are equal in length. Okay, I'm putting a tick on them, and these two sides are also parallel, indicated by the arrows. We want to prove that this quadrilateral is a parallelogram. Obviously it looks like a parallelogram, and if you do construct such a setup, draw two lines that are parallel and equal in length and connect up the ends, you will find that these two lines are also parallel and equal in length. But we want to prove that, okay? So what do we do? Well, we draw into two diagonals. Next we look at these two triangles. We can prove that these two triangles are congruent fairly easily. Now we have a pair of Z angles, or alternate angles here. I'm calling them A and B. Now I'm going to label angles with capital letters. It's just much easier to read and to see clearly what's going on. Okay, if you want to, you can use points to represent an angle. You can give these 3 points names, but that's just too difficult to read. Okay, it's much easier just to call, say, this one A and this one B. Okay, I'll just use capital letters for angles rather than for points. Alright, so A is equal to B because this line is parallel to this line, so we have a pair of Z or alternate angles formed. And of course we have another pair over here. I'll call this one C and this one D. C is equal to D for the same reason. Those are Z angles. Okay, remember that's only true if this line is parallel to this line. So now we can see that both of these triangles are similar. They're equiangular triangles. Okay, if two of the angles are the same, well, the third angle is automatically the same. Actually, it's very easy to see that these are the same because they're opposite angles. Now, what else have these triangles in common? Well, they have the same side. Okay, so I'll call this, well, we can call this side X. I'll use a small letter for the side, and I'll call this side Y. So X equals Y. So X is this distance, and Y is this distance. Well, that's a given. Okay, that this side equals this side. So we see that the angles are the same in both of these triangles, and one side is the same. So we have this angle side angle situation. So by angle side angle, triangles are congruent. So I haven't actually given the triangles names, but I'm referring to these two triangles. Okay, when I said angle side angle, I meant this angle, this side, and this angle are the same as this angle, this side, and this angle. Okay, there's angle side angle situation that was discussed in previous videos. So the two triangles are congruent, so that means that the other sides are the same. So which sides are the same? Well, the side opposite B is going to equal the side opposite A, okay, because A is equal to B. So this side equals this side here. So I'll put two dashes on this. I don't want to put one dash on it because I've used one dash on the lines X and Y. And the sides opposite C and D are the same. So this side equals this side here. So I put 3 dashes on this, and I have to put 3 on this. Now remember what we are trying to do. We are trying to prove that this line is parallel to this line, and that they also have the same length. To do that, we look at these two triangles. Okay, so I won't give them names, you can give them names. I just want to get the idea across. So what do we notice about these two triangles? Well, we see that we have two sides the same in both of them. Also, there's an angle that's the same. We have a pair of opposite angles here. This angle equals this angle. Okay, so you can state that, you can give these names. You can say P equals Q because they're opposite angles. I won't bother writing that down. So this side, this angle, and this side are the same as the other triangle. So here we have a side angle side situation for both of these triangles. So by side angle side, okay, side angle side for this one and side angle side for the other one, the triangles are congruent. So now I'm referring to these two triangles, not the previous two. Okay, so I'm referring to these two here, of course. So these two triangles are congruent, and if they're congruent, they're equal in every way. So in particular, the side that's opposite equal angles are equal. So the sides opposite the dotted angles are equal. So straight away we've proven that this side equals this side here. Put 4 ticks on it. Okay, so the two triangles are congruent, so all the sides are the same. So those sides are the same. Now how do we prove that these two lines are parallel to each other? Well, to do that we need to show that this angle here is equal to this angle here. Because if it is, we have a pair of z or alternate angles. If these angles are equal, then this line is parallel to this line. And that's easy to see because this angle here, which I should probably do in blue, is opposite the blue side, and the same here. So this angle equals this angle. Okay, so I'll just put a tick on this and a tick on this one, or maybe 2 ticks on it, because it's opposite the side with 2 ticks. So these two angles are the same. So we have a pair of z or alternate angles, which means that this line is parallel to this line here. Okay, so that's the end of the proof. I haven't written down all the details, but I just want to get the ideas across. In the parallelogram A, B, C, D, DE is perpendicular to AC, and BF is also perpendicular to AC, as you can see. So we want to prove that this quadrilateral in here, EBFD, is a parallelogram. Okay, so first of all we notice that DE must be parallel to BF, because these two lines, DE and BF, make the same angle with the line AC, namely a right angle. So this line must be parallel to this line here, okay? They make the same angle, so you could say that we have corresponding angles. Okay, so this line AC is a transversal that cuts across these two lines and makes the same angle with both of them. So DE is parallel to BF. Now AC is the diagonal of the parallelogram ABCD, and we know that the diagonal bisects the area of a parallelogram. So the area of this triangle here is the same as the area of this triangle here. Okay, so how would we get the area of these two triangles? Well, we could use the diagonal as base. So for example, to get the area of triangle DAC, we'd multiply the base, which is AC, times the perpendicular height DE. We'd also get half of it, but that half factor of a half doesn't really matter. So here it's written out, area of triangle DAC is half the base. Well, the base is AC times the perpendicular height, which is this line here, DE. And that's equal to the area of triangle ABC, because a diagonal bisects the area of a parallelogram. But the area of the other triangle, ABC, is half the base. It's got the same base, AC, but its height is BF. Okay, so we take the diagonal as base, and if the diagonal is base, then the lines DE and BF are the perpendicular heights of each of these two triangles. But we can see straight away, obviously, that that leads to the fact that the heights are the same. So DE equals BF. So not only is DE parallel to BF, but DE is equal to BF in length. So how do we prove that DEBF is a parallelogram? How do we prove that the remaining two sides are parallel and equal in length? Well, we just used the result of the previous part. We saw that if we have a quadrilateral where two sides are parallel and equal in length, then the quadrilateral is a parallelogram. So we just invoke the previous theorem. So this must be parallel to this, and these two lines have the same length.